Hey guys, welcome to the video tutorial for conservation of energy. But here we are going to be dealing with a pendulum when it has been released from rest at a certain known height or maybe a known angle or something like that. So let's say that I know that my pendulum has a length of, let's say, 5 meters. And it swings up to an angle of 25 degrees. And I want to know the speed it's going to have at this, its max speed. Well, its max speed is going to occur here at this equilibrium position. Well, to do that, I know that starting out, if it's released from rest, I only have potential energy. And then at the bottom, when it's swinging through, what I can do is make that my y equals 0 position, so that I only have kinetic energy, which is 1/2 mv squared. So again, I can cancel my v's, so I'm left with gy equal to 1/2 v squared. Now I know g, I'm looking for v, but I need to know this y. In other words, I need to know this height right here. What I can do is utilize the fact that, again, I gave you the angle for a reason. And so if you think about it, you form a right triangle right here with this length being 5 minus y. This whole length being 5. So what I can do is utilize the fact that cosine of 25, in other words, cosine of theta, is x minus y over x, where x is the length of my string or rope, and y was the height. Again, cosine of theta is adjacent over hypotenuse, so that's 5 minus y over 5. So here we go. Cosine of 25 degrees is equal to x minus 5, or excuse me, 5 minus y over 5. And I'm left to solve for y. Well, cosine of 25 is just 0.9, we'll go 0.906. And that equals 5 minus y over 5. So what I can do, multiply both sides by 5. So this is going to be 4.53. I'm going to come over here. 4.53 equal to 5 minus y. Subtract 5 from both sides. And I'm left with negative 0.46 equal to negative y. So cancel those negatives. So my y is 0.46 meters. Well, now that I know y, I can take it, plug it in right here, and solve for v. So 9.8 times 0.46 equals 1/2 v squared. And I'm left to solve for v. So 9.8 times 0.46 gives me, like, let's just call it 4.6. And then that equals v squared, or excuse me, 1/2 v squared. So multiply both sides by 2. So I'm left with 9.18 equals v squared. Last step is to square root both sides. And so 9.18. That gives me a answer of, let's go with 3.03. So velocity is 3.03 meters per second. So, again, this equation is crucial to know how to work, and it's crucial to know that you can set your potential equal to your kinetic. So I could change that up and say, well, how long is my rope if I know the velocity? Again, you would work backwards, solve for y, and then use this equation to solve for x. So that's an example problem that you can expect for your free response dealing with conservation of energy for a pendulum.